Every day, heavy trucks, buses, and machines move our world. But deep inside these engines, one small component controls the power, the smoke, and even the emissions. It's called the Electronic Unit Injector, the EUI. Unlike old systems with a separate fuel pump and injector lines, an electronic unit injector combines a high-pressure pump and an injector nozzle into one compact unit mounted directly in the cylinder head. Mechanical force from the camshaft, plus electronic control from the engine ECU, working together in one tiny, precise device. Inside one EUI, you'll find an injector body, sealed into the head with O-rings and a copper washer. A plunger and barrel, acting like a microscopic high-pressure pump. A return spring that pushes the plunger back after each stroke. A solenoid valve, controlled by the ECU. And at the tip, a nozzle and needle that finally spray the fuel into the combustion chamber. It looks simple from outside, but the tolerances are so fine that even a speck of dirt can cause problems. The EUI is a partnership between mechanical and electronic control. On one side, the camshaft and rocker arm push down on the injector plunger. This mechanical movement creates the high pressure needed for injection. On the other side, the ECU energizes the solenoid at exactly the right moment. It decides when injection starts, when it ends, and how much fuel goes in. Let's slow things down and watch one injection event. Step 1. Filling the cam lobe is away. The spring pushes the plunger up. Fuel from the gallery flows in and fills the plunger chamber. Step 2. Start of plunger stroke. The cam lobe begins to lift the rocker. The plunger moves down, but the solenoid is still off. Fuel simply escapes through the open spill port, so there is no injection yet. Step 3. Start of injection. Now the ECU says, "Inject." It energizes the solenoid. The spill port closes. Pressure rises rapidly in the chamber until the nozzle needle lifts and a fine spray of diesel shoots into the cylinder. Step 4. Main injection. As long as the solenoid stays energized, fuel continues to flow. The length of this electrical pulse controls the fuel quantity. Step 5. End of injection. The ECU cuts power to the solenoid. The spill port opens. Pressure collapses. The nozzle closes instantly. Injection stops. Clean and sharp. Step 6. Reset. The cam rolls over. The spring lifts the plunger back up, and the injector is ready for the next cycle, waiting for the ECU's next command. So why do manufacturers love the EUI system? Because it offers very precise timing, controlled by electronic maps in the ECU, accurate fuel quantity, matched to load and speed, high injection pressure right at the nozzle for excellent atomization, lower emissions and better fuel economy, fewer external high-pressure lines, making the system more compact and safer. All of this helps engines meet strict emission laws, while still delivering the torque drivers need. But like any precision system, electronic unit injectors have their weak points. Common issues include O-ring failures, causing fuel in the engine oil or oil entering the fuel gallery, solenoid or wiring faults, leading to misfires and fault codes, plunger and barrel wear, reducing injection pressure and power, nozzle carbon buildup, affecting spray pattern and emissions. In the workshop, technicians rely on ECU diagnostics, cylinder cutout tests, and careful inspection to find which injector is the culprit. You may never see it, but inside every modern diesel engine, the electronic unit injector is working thousands of times per minute, balancing power, economy, and emissions with every single pulse. A tiny mechanism with a massive job. This is the unseen technology that keeps heavy vehicles working and the world moving.